Now we are going to see the detection of complex formation by using basic principles of various methods. In that methods, in our syllabus it is given as chemical properties, solubility, color, pH, conductivity and magnetic susceptibility. Based on these particular factors, how to determine the complex formation. Complex formation we are going to determine based on these properties. Let us discuss one by one very clearly by using different examples. If you are looking into the chemical property, right? So for example, if you are considering metal and it is going to combine with ligand, it is going to form complex, right? If you are considering metal and combining with what to call ligand, it is going to form metal ligand complex, right? I am going to show you a complex in which K3 Cu Cn4. So this is the, obviously this is plus 3, right? This one is going to right, this complex name is going to be potassium tetracyano cuprate 1. So in this complex we are going to check this particular topic called chemical property, right? First one, this is going to copper cyanide. Copper cyanide is going to react with, potassium cyanide is going to react with copper ions, right? Potassium cyanide is going to react with copper ions which are going to form K3 Cu Cn4, right? This complex, right? Once after forming this particular complex, this complex cannot show the not plus 2, it is going to be plus 1, cannot show the properties related to Cu plus before reacting. What it mean? Before reacting the copper ion is there, right? This can give positive test for the presence of Cu plus ions, whereas this complex cannot give the test for the Cu plus ions even though it is having copper, because it is involved in the complex formation, right? As it involved in the complex formation, this will not show the properties or tests which are related to Cu plus ions. This is the way we can identify the formation of complex by using chemical property. Again I am repeating why this chemical property, how this chemical property is helping to identify the color. This chemical property, once after reaction, right, that is forming a complex. That formed complex is not going to give the test for the individual copper ion even though it is present in the complex, because it is a complex. If it is individual ion like this, it will give you the test related to copper ion, right? In this way our chemical property can help us to find out the formation of complex. Now we are going to discuss about solubility, right? Solubility. Now solubility, if you are checking clearly, AgCN, silver cyanide is going to be sparingly soluble, not completely soluble, sparingly soluble compound which is going to react with potassium cyanide. AgCN is going to react with potassium cyanide which is going to give AgCN taken twice potassium. So this is a sparingly soluble compound upon reaction with potassium cyanide and going to give you a complex. So here once after forming this complex is going to be completely soluble complex it is, completely soluble complex. So what we have to understand here, this sparingly soluble AgCN after formation of complex, it is going to give you a completely soluble complex. That means solubility varied. The indication of this complex is giving is it can be understand easily from the solubility factor. Solubility is getting what is happening to solubility is increasing. Solubility is increasing due to the formation of complex, right? From the solubility change, we can understand that complex is forming. That's what the second point is all about. Complex formation by using solubility. Now we are going to discuss about third factor, that is going to be color. Now if you are looking into color, right? Now we are going to discuss about the color, how it is going to help to indicate the color complex formation. If you are looking into the copper sulfate color is blue color, but very light blue color, just like a sky blue color, right? Once after forming complex with ammonia, it is going to give you tetraamine copper to sulfate. Tetraamine copper to sulfate is the complex which is forming after reacting with copper sulfate. What is the color of copper sulfate? Sky blue color, light blue color. Here the color is going to be intense blue color, or royal blue color, This royal blue color will indicate the formation of complex once after reaction between this copper sulfate and ammonia. So copper sulfate and ammonia are reacting together, which is giving a complex. How this complex formation can be identified by a color change. How the color is changing by a light blue color to an intense blue color, which is going to be a royal blue color. The royal blue color is going to indicate the formation of complex. In this way, color is going to help us to indicate the complex formation. Now we are going to look at the next point, that is going to be pH. How pH is going to indicate the formation of complex? How pH is going to indicate? So metal and ligand together forms complex, metal ligand complex. This metal ligand complex, how to understand by using pH. In this one, ligand plays an important role. Ligand, it can donate protons or it can accept protons. Accept protons means ligand acting as base. Donation of protons means ligand acting as acid. What happens if ligand is donating protons? What happens? pH increases. Whereas if ligand is accepting protons, what happens? The pH decreases. Right? During complex formation, what is happening here I am explaining. Ligand can play in two roles here. One role, it can donate protons, one role it can accept proton. While donating proton, the pH will increase. While accepting proton, the pH will decrease. Obviously the pH is indicating the complex formation either increasing way or decreasing way. Overall the pH is changing. The change in pH changing. The pH changing is due to complex formation. What we are discussing here, the formation of complex based on pH value. The pH will change if the complex is forming. How it is changing? It is increasing or decreasing based on proton accepting or donating. If you are considering here, right, the pH is increasing and pH is decreasing here, right? And pH decreasing means, what is the meaning of pH decreasing? pH is decreasing means what? And pH is increasing means what? Right? Obviously, if you are considering an example, going to take as ammonia. This ammonia is going to accept protons. Why? Because going to is a base and it's going to accept protons as is a base. And so what happens? As accepting, pH decreases. So pH decreases, that means it's more acidic. Now moving on to here, pH increases, more basic. So whatever may be the consequences, whether it is more acidic or more basic, that is not the most important point here. Change in pH is important here. So why the pH is changing? Because complex is forming. So indication of complex from the pH is very clear from here, because pH is changing. Now we are going to discuss about conductivity. Based on conductivity, how we are going to identify the formation of complex. Conductivity. Now we have to understand how the conductivity occurs, right? How a solution will give you conductance based on ions. If ions are present, they will give you conductance. Without ions, there is no conductance, right? If ions are present, then they will give conductance. More number of ions, more conductance. More number of ions, more conductance. If you are considering an example, copper plus 2 and going to react with 4 ammonia molecules and going to form a molecule that is CuNH3 taken 4 plus 2. How many ions here? 1 ion plus 4 ions gives rise to how many total? 1. So we can see here very clearly the number of ions. How many number of ions here? 5. How many number of ions here? 1. So the number of ions got decreased here during the complex formation. That means what will happen to conductance? Conductance is proportional to number of ions, right? Conductance will decrease. Why? Because the number of ions decreased. It is directly depending on the number of ions. More is the number of ions, more is the conductance. Here we can see once after forming complex, the number of ions is getting decreased and so the conductance is decreasing. So the decreasing conductance is giving the information of the complex formation. Here it is very clear that a complex is formed. Imagine you are having a copper plus 2 ion. Imagine you are having a copper plus 2 ion and forming a complex with ammonia, right? And after forming complex, how many ions are there? 1 ion. So number of ions decrease. So directly it is proportional. It is proportional that complex is forming, right? In this way, conductivity is helping us to find out the complex formation. Now we are going to discuss about magnetic susceptibility. How that is magnetic susceptibility is going to help us to understand the magnetic susceptibility. Magnetic susceptibility is going to understand the complex formation, right? Now magnetic susceptibility means what? Magnetic susceptibility means it's based on magnetic property. Based on magnetic property, we can understand the complex formation, different complexes. For example, iron is there, iron plus 2. It is going to react with water. The same iron plus 2 is going to react with so called Cn minus ions, for example, right? It is going to form FeH2O dot 6 2 plus. It is going to form a complex FeCN6. How many 4 minus will come into picture? And in both these cases, Fe is in plus 2 state only. Now how magnetic susceptibility is going to help us? Because these two are different complexes, right? So these two complexes can be understandable by using their magnetic susceptibility. If you are considering here, this is going to be a weak ligand which we already discussed in the past classes. This is going to be strong ligand. This also we have discussed from the spectrochemical series. So from this one, if you are looking at carefully, right, it will undergo splitting. That is T2Z and EZ. As H2O is a weak ligand, here what happens? High spin complex will form. High spin complex. Why? Weak ligand. That means what is the Fe plus 2 oxidation state configuration? D6. So 6 electrons are going to fill 1, 2, 3, 4, 5, 6. T2Z4, EZ2. The same way here, if you are looking at it clearly, right? Here it is T2Z and EZ. Here in this case, even though it is D6, it is strong complex. So going to form low spin complex. In this low spin complex, how the electrons are going to feel? 1, 2, 3. Even fourth electrons are going to enter here only. 4, 5, 6. And E is 0. So it is going to be T2G6, E is 0. How many unpaired electrons are here? T2G4, E is 2. If you are considering here completely, right? 2 unpaired electrons from here, 2 from here. Total unpaired electrons is equal to 4. Total unpaired is equal to how many? 0. Already just now we have discussed that magnetic momentum formula. What is the magnetic momentum formula? Root over n into n plus 2 Bohr magnetons. Right? For this complex, what is the magnetic momentum is going to be? 4 unpaired electrons. Root over 4 into 4 plus 2. How many is going to be? Root over 4 into 16, 24. It's going to be approximately 4.9. Already we have seen same thing before also. And here if you are comparing here, right, mu is going to be how much? It's going to be 0 and 0 Bohr magnetons. So one is going to be diamagnetic. One is going to be paramagnetic because that is going to have some magnetic momentum. So based on this magnetic momentum, we are able to understand which complex is forming with iron, whether it is low spin and high spin. So the complex formation can be understandable by using magnetic susceptibility in this way. For this example, it is very clear that one is paramagnetic, other is diamagnetic. Based on the magnetic momentum, we are able to understand the complex formation. In this way, we can understand the complex formation by using color, solubility, conductivity, pH, and then magnetic susceptibility. By using all these factors, we can identify whether complex is forming or not.